So, Colin, what are some of those AI tools and techniques used in industrial settings? And how do these tools, like machine learning or deep learning, fit into the larger industrial applications market? Can you perhaps explain the role of natural language processing and computer vision as well? There's a lot there.
Yeah, that's a broad question. And industrial AI really can use more than one tool and technique. It's not either or in this field. I mean, that's why we need data scientists, and we talk a lot about industrial grade data scientists, people that understand the industrial domain. In other words, they understand manufacturing, supply chain, product design, process design. They need to understand the very specific requirements of the industrial domain, along with some of our compliance, security, safety, and health considerations. But they've got a lot of tools at their disposal, and we've been using, and frankly, a lot of AI is kind of started with symbolic AI. If you remember, kind of heuristics, rule-based expert systems. Symbolic AI was all the rage back in the 50s, and that was the pervasive AI tool and technique for decades. And I'm not going to go through the whole history of the evolution of AI, but to a large extent, machine learning addressed the fact that that those systems just got too complex and too difficult to maintain, and they weren't adaptive. And so, really, machine learning kind of took over as we had more and more access to data. The cost of accessing that data and processing that data got cheaper and cheaper, particularly with the advent of GPUs and their applications to a number of machine learning tools and techniques. But you've kind of got machine learning, neural networks, various forms of neural networks, whether they're kind of convoluted, artificial neural networks. There's various techniques that get deeper into deep learning techniques, and then you get a lot of specific applications and optimizations, if you like, of algorithms and approaches to training that really are optimized, let's say, for natural language processing, which are used broadly in consumer. You know, we're used to talking to devices now and being somewhat understood. So that's natural language processing, but it has a lot of applications in manufacturing when you need to keep your hands free. Then you may need to talk to a system to get it to perform an action for you. Or you may be trying to communicate in noisy environments in manufacturing, and so it can help with enhancing communications in a number of use cases. So there's a lot of applications of natural language processing and voice recognition systems broadly. Then you have kind of, sometimes it's called machine vision, sometimes computer vision, but basically taking video or pictures and being able to process those, do object or shape recognition, and beyond that, kind of looking at, is somebody uh, using a camera, is somebody moving into a hazardous environment, or are they not wearing a hard hat or other safety gear, or can be used for security, intrusion, or loss prevention type use cases. So there's a number of applications of kind of that computer vision or machine vision. Very often it's called machine vision when you're looking at industrial use cases, because it's clearly a skill that robots need to have. As they're moving around and interacting, they need to be able to recognize objects and shapes. So, computer vision or machine vision is a major field that, if you were at Hannover Messe this year, you will kind of have seen the rediscovery of machine vision that was kind of, I wouldn't say anything net new, but just a lot more of them, a lot more accurate. Clearly, the cost of using machine vision has come way down with all of the other investments in AI infrastructure and the advancements we've made in being able to process massive amounts of data and the fine tuning of all the models for computer vision. So hopefully that gives you a sampling. That wasn't by any means comprehensive. Um, we might want to talk about deep learning